This video will be a more in-depth look at how I built my Raycaster using a simple widget within Unreal Engine. This project was done over the course of about 3 weeks and has probably been one of the coolest things I've been able to work on, so let's hop into how I made it. Before we begin, let's discuss what a Raycast even is. In this example I have a 6x6 grid, with the white blocks representing walls and the black blocks representing empty space. Now, let's add a player onto our map. In this 2D grid they can move forwards and backwards and rotate left and right. The next thing we're going to do is draw a line going out from the direction the player is facing that will stop whenever it hits a wall. This line will essentially tell us the distance between the player and the wall. Next, let's use the distance we got to draw a vertical line on the right. The longer the distance from the player to the wall, the smaller the vertical line. Finally, let's repeat this about 20 times. As you can see, we get what looks like a 3D world on the right. This is the magic of raycasting. Now let me show you how I did it and go a bit more into depth with how it all works. When I started this project, I experimented with a few different ways that I could go about making something like this work. I originally started trying to make the Raycaster in C++ using things like render textures, HUDs, and slates, but for whatever reason, Unreal Engine makes it extremely difficult to access the primitive drawing functions I needed for this project, so I ultimately came to the decision to switch over to using a blueprint widget. Everything is done using the onPaint function within the widget blueprint. This allows me access to the primitive drawing functions we need, such as the draw line and the draw box nodes. These are the building blocks for the entire project. I began work on the 2D grid map. I created an array of 1s and 0s, with 1s representing wall spots and 0s representing empty space. I then added a player character that can move using the WASD keys. Okay, so from this point forward there's a lot of math involved. Like, a lot. So I'm not going to go super into depth with everything, but I'll try to explain it as best as I can. So in order to create the rays, we need to get the player's position and the player's angle. Using
trigonometry,
you can get the tangent of the current player angle, then multiply and divide that by the height of each grid cell, which in my case is 40. With this information, we can determine each exact position the ray crosses over into a new grid cell. Then we can get that new grid cell's value, which if it's a 0, it will keep going, but if it's a 1, it stops the line, completing the ray. Then we loop this about 60 times, incrementing 1 degree each time. Okay, so we have the rays. Now we move on to the 3D part. So in order to draw the wall lines, we need to get the length of each ray, which we can do so using the distance formula. Now we can't just use that value, we have to divide this by the 3D screen times the grid height. This will make it to where the bigger the ray is, the shorter the wall line will be. With this value, we can finally draw the lines for the walls. And there you go, a working raycast. Isn't that neat? But I wanted to go a little further. I wanted to add textures, just like in the original Wolfenstein 3D. Unfortunately, Unreal's draw line node only works with solid colors, so I knew I'd have to think outside the box on this one. After some thinking, I decided I'd once again test my luck with C++ to create a custom node to draw lines with a texture applied to them. And wouldn't you know it, I actually managed to get it working. Maybe C++ doesn't hate me after all. How I achieved this was by drawing each line 1 pixel at a time. The node takes in a texture and then gets the raw pixel data, adding each color needed to an array that's then put onto the pixels in that order. In order to get the correct position along the wall, I also added in a fixed float, which takes in a decimal between 0 and 1, then multiplies that by the texture width, getting the exact X position needed to put onto the line. And that's how I did everything for my project. As you can see, the way I've set it up is extremely easy to modify and create new maps, levels, and even add to the program. If this is something that interests you, I would highly recommend trying this for yourself, as it was a super cool learning experience. Anyways, that's all from me. Thank you so much for watching.